Thank you so much for having me, Kelly, Manny, and thank you, Rochelle, for making the connection here. A little bit background about myself. Based in San Diego for the last decade. Went to UC San Diego, where I did my undergrad and PhD. I was building camera systems for robotics and self-driving vehicles. And my hypothesis was that we could be building cameras to replace those very expensive LiDAR systems that you see on top of the Waymos. Because those things are expensive, right? Like if you look at Waymo, we're talking about, $200,000-$300,000 just for the LiDAR system itself. But with cameras, if my theory was correct, we could build it for thousands of dollars instead of hundreds of thousands of dollars, and make the ranging and detection a lot smarter to detect people on the road, and that. I then knew many folks in the civil engineering space, companies from NV5 and others, and they asked me, hey, can we use the camera tech that you built for ground-based mapping? And we kind of scratch our heads like, yeah, probably. And that's when this journey started. So 4 years ago, my co-founder Shreyas, we started literally in my garage up in Mira Mesa, and we started building prototypes. So at first we had a big rover system with many cameras, like a little Christmas tree. And we started deploying it on McCarthy's construction job at UC San Diego. So they were building a large research building there. And we realized that robots weren't really good, right? Stairs, gaps, cables, things to navigate is hard for a robotic system. And we realized humans were pretty good at it. And that's kind of where the idea of our handheld photogrammetry-based system came from. So what we do today is build and sell hardware and software, right? So this is what the hardware looks like. It's a little handheld system, and like this. You can see a little sketch out on the top right in my background here. And essentially, construction projects, anywhere from survey into civil into vertical construction, will leverage our technology to capture spaces, areas, using our imagery and survey grade GNSS. And then as the data goes to the cloud for the processing, we transform those images into a 3D point cloud, a 3D model representation of that space, with accuracies that are equivalent to what you'll use similar to a total station or LiDAR scanner, but a lot faster, a lot cheaper, and a lot smarter, because everything we do is AI based. And what that allows us to do is understand the scene. Can we start detecting different types of objects, object classes, things that will allow us to do more intelligent BIM model creation and downstream work. So today we are based and headquartered in Serena Valley, so down the street here. We're a team of 35. We say there's nearly more PhDs than we have employees at the company, so it's a very research heavy effort here. We are distributed internationally, so we have customers all across US, Canada, Europe, Australia, and South Korea today. So we're starting to get a global presence. We're super excited about where we're going, right? It's been a beautiful journey thus far. And today the goal is to walk you through a little bit about the technology, show you a few examples, and I want to keep it very interactive. So feel free to jump in with questions towards the end, and then we can go through those. So I'll pull up a couple of slides. I'll keep it brief because I don't want to do death by PowerPoint, and then we'll go into the demos. So the first thing I want to touch on is a little bit about survey technologies out there. So you guys might be familiar with, I'm going to say total stations, which are probably the highest accuracy, most commonly used piece of geospatial tech on the market today. What's great about them is you set them up, you shoot them in, you localize them, and they're reliable, right? Then you've got the drone space, you've got survey grade GNSS, so basically just GPS measurements. And where Looq falls in is a hybrid, right? So we are able to provide very high accuracies because we have very good pixel triangulation in our algorithms and our cameras. We've got GNSS built into the system, so you can figure out where it is. And we've got the benefit of being on the ground, which means you've got the perspective of everything you see around you. And since the world is built from the ground up, it's, as I say, one of the best ways to be able to capture that environment. So a quick introduction on how our technology works. So what you'll see here is our 4-camera system carried by an operator. Battery sits on your belt, plug it in, hit start on the phone. It captures imagery as you walk around. And at the end of the day, you bring that camera back to your office, hit upload. the images go to the cloud where the AI will then reconstruct it. And we have written our own algorithms to do that very accurately and very quickly. And what you see here is kind of the output. So this is a 100% ground-based capture where we can then virtually re-render all the perspectives from that site, right? And what that means is that within minutes, you can walk a construction job. Is it a bridge, civil job? Is it a building that you're building? You're looking at your concrete pours. You're looking at your stub-ups, your rebar locations, your anchor bolts, your PT cables. You'll shoot them in within seconds, literally, and then be able to have that record of that asset in the long run. So a little bit about the technology behind it. So as I said, we're 100% camera-based. So we have no lasers, no LiDAR whatsoever in our systems. And we're probably the only system on the market that is 100% camera-based. The reason why we are very accurate is because we have put a lot of research and development into the camera system itself. So we can, for example, figure out on a power line to, I'm gonna say, under a centimeter accuracy where that attachment point is, right? Which is what really makes the system a survey-grade system rather than a general 3D camera. And we have a very complex set of calibration procedures that are done automatically on the system so that you don't have to maintain the equipment, right? You don't need to send it back every year for a recalibration process. It's done, built, shipped out, and then you will forever be happy with the quality because it's a self-calibrating system. And because of that image accuracy, we also have a lot of resolution, right? So the way I like to describe it is when you have a LiDAR system that shoots pulses of light to take a measurement, you're going to be maybe capturing 50 to 100,000 points per second. With Looq's technology, we're capturing on the order of 100 to 200 megapixels, 100 to 200 million point samples per second. So we're fundamentally capturing a lot more spatial density and resolution, which allows us to do a very quick job of walking around the site while maintaining those geospatial accuracies. And that's kind of the secret sauce behind it. So moving a little bit towards some of the applications, right? So we have a large focus towards survey companies and of course the construction side as well. We help achieve any of the following tasks and a lot more, right? So basically everything as it comes to do boundary surveys, initial stakeout verification, land surfacing, volumetric measurements for earth movement, then into the more design verification or construction verification job as well, right? So we really spend the full stack. And what we normally see with clients is that we allow them to save a lot of operational cost and time as it comes to fielding, right? For example, if you're spending the time to shoot in and verify every anchor bolt on a site, that you're going to be at it for many, many hours. With Looq, you're at it for a few minutes. So it's a shift in being able to capture detailed data in a very short time span. And then the fact that we can now do this means that you can standardize on a daily, weekly process for capture, whereas before you wouldn't have been able to, right? I know a lot of construction companies that before were not able to do a weekly or scan of a site because of a LiDAR setup, maybe taking 2 days to scan a whole site. But with Looq, you can now do it daily. And that means that your owner operator, the asset owner, is going to get more value out of what the GC is building. Is going to be more transparency on the job site. There's going to be better verification for subcontract management. So there's a lot of different applications that are really, really valuable around this. And first, I see your question, would this be considered photogrammetry? 100%. Yeah. So we are a custom photogrammetry SLAM AI system. So it's a bit of a hybrid between those, but that's really where we sit. The number one question I often get is accuracy. Is how accurate is it? Can we trust it? And the short answer is yes, you can trust it. We can have 3 tiers of process. The first one is out of the box PPK, right? So we'll tie in to global reference station cores and others. Then if you have a Trimble system or like a GNSS already, so let's say you have an R12 GNSS, you can use that and do a local PPK processing to get those global coordinates. And then a lot of you folks, I assume, are working in local coordinates, which means that you have a local coordinate grid system for your site and have a set of reference points that you're already set up. We support control point references. So what that means, you just walk around, shoot those in as you walk around, and then that's going to give you the highest accuracy. And generally speaking, we're seeing about 100 residuals across those global and relative accuracies when you use control points, right? So that's really a ability to do a lot of detailed, quick survey across your sites. So with that, I just want to do a very quick comparison about some of the quality of the point clouds that are coming out of this. Some of you may be familiar with, for example, the RTC 360, which is a pretty great LiDAR system that is stationary. So you have to set up the tripod to be able to capture your data. Looq overall equates in that noise profile to a lot of those terrestrial laser scanners. So what previously would cost you maybe $50,000, $60,000, $70,000 for a terrestrial laser scanner, you're going to be looking at it in the $15,000 for the Looq system. So a lot cheaper and a lot faster on top of it. So that's our goal is to make this accessible to everyone. So since time is a little on the shorter side, I'm going to show up a quick example on what this looks like in our web interface. So you can have a quick teaser of that, and then we'll open it up for questions. So pulling it up here. What you see here is our web interface. So this is a secure cloud environment. So you can type in your credentials, two-factor authentication, security measures to make sure this is in compliance with all of your clients. You have your own account, and then as soon as you upload the data from the camera up to the cloud, you'll see a little icon here that shows, hey, your data set's ready. I sign into a coordinate system that triggers the processing, and then generally anywhere between a couple of hours and at the latest about 24 hours, you'll have the data sets returned back to you automatically in this web browser interface. First thing you'll see here is that this red path is where the operator walked. So this is a quick road construction site. So we'll pull up an image here. This opens a new window. And since you guys can't see other windows, I'm going to pull it up here. And this is where you'll see the quality of the images, right? So you'll be able to look around, see everything that was captured for that site. So we've got the top camera that goes up, the front camera, the left camera, and the right camera. Going back to here, what I'm going to turn on is the ortho view. So this is the top-down generated image mosaic that we generate at the same time as the point cloud. So what you'll see here is that this looks like it was captured from a drone. Well, it was not. It was captured 100% from the ground. And all of this is measurable and scaled, right? So geo-referenced. So in here, you'll have the coordinates up in Canada and then the distances, right? So that are all correctly automatically assigned. So this you could be bringing in as a backdrop. You can do this for floors, right? So you can do this for ceilings. You can do this for different kind of profiles on the site, and it's a very useful way of doing a very quick verification of everything that's actually built. So moving over to the 3D model, this is what this looks like. So you can see that the point cloud here is going to be very dense. We have many millions of points, and the surfaces that you'll see, I'm just going to do a quick focus here, are very crisp. So very little noise in that surface, which is what's required to hit those accuracies, and very high data fidelity across that. Those of you who have used photogrammetry will probably be familiar with doubling, misalignments, issues, noise. And that's one of the reasons we've built our own hardware and also been able to optimize the algorithms to be able to support that. And our goal is to be able to make sure we can provide you with a reliable data set to be able to then use across your projects. So the last thing I want to finish off with is a little bit on where does this data go afterwards. So many of our clients will bring this into, for example, Revit, and then export that to Navisworks. So if you want to do clash detection, different use cases, that's a really big focus on that. You can import this into Trimble Business Center if you're doing a little bit more on the, say, survey and horizontal construction side. You can bring this into Bentley. So we have many folks on the civil front that will leverage some of the bridge CAD tools to do that. So it's a very diverse and importable data set. The export is an LAZ file. So if you go to outputs, hit point cloud download, you'll get that LAZ file. You get the GeoTIFF as the ortho and the JPEG imagery as well, right? So we really provide the full output solution for that. So with that, I want to open up for questions, and then we can always pull up more data sets and examples with those questions. So I see that there was one that came in from Kevin. How well does the system work inside buildings, particularly with some low light situations? Is it mostly designed for exterior situations? Great question, and I'm glad you asked because I didn't touch on that. We are primarily an exterior system, but we do have these strobe lights. So these white rings around here are actually strobe lights for the system to illuminate dark areas. So what I'll do here is I'll pull up a quick example of a manhole. So we do electrical rooms and all of that. So that's totally fine to do interiors with Looq. We do not need GPS enabled environments to capture areas. So we can really rely on just GPS denied areas as well. And those areas can be fully reconstructed. So we're going to go in here, show you what that dark interior space looks like and the level of detail that we capture with that. So we're just going to do a little flipping cross section here. Yeah, so the short answer is anything short range where we have enough light, we can absolutely cover with the Looq system. So the circles I noticed in the walking path, are those recommended for accuracy? Yes, and I'll expand on that a little bit. Because we use images to figure out where the cameras are in the photogrammetry algorithms, having a good distribution of those really helps us. So in drones, you do a lawnmower flat pattern to be able to guarantee the robustness in some of those camera alignments. And in LiDAR SLAM systems, so the handheld LiDAR systems, you need to do something called loop closures. And these loop closures mean that around building sides and corners, you're going to have that reliability in that reconstructions because it aligns those laser scans individually. In our case, we're going to be robust in all environments where you have good image textures. So we don't necessarily need to do loop closures in the same way as a LiDAR system would. If you take it onto a parking lot where there's no vertical structures, where a LiDAR needs to be able to align those faces, we will be fine because we have a lot of image points that we use for our matching. A LiDAR system will drift, for example. So we're a lot robuster in a lot more scenarios in our alignments than a LiDAR system will be. But it still helps having a bit of variety in viewpoints to be able to focus on that. Next question. Does your software eliminate noise or moving objects? Yes. So anything that is people and vehicles are automatically removed in both the images and the point cloud. First of all, this is for privacy reasons, so that workers don't have to worry about that or anyone else in the scene. And the second part of it is motion. So if you are going downtown and have a busy sidewalk, you can capture Looq and you will have all of that removed automatically. The main usage so far is, I think it's a wide variety, right? We use it for verification on construction sites. So basically doing a daily or weekly as-built capture. So really useful on that end. The other part of that is to do quick verifications on very specific items. So we've seen it used for concrete pours, where, for example, they had to check the heights of offsets in a complex school building that they didn't know if it was poured too high or too low. PT cable localization, right? Being able to know where your post-tension cables are before you pour, because afterwards you're going to have to hire someone on the call to do a GPR scan to figure out where those are. So being able to shoot them in virtually with the geometric accuracy to know where you can then drill around is going to be very critical. Otherwise, we also have seen it for a lot of the initial survey applications, volumetric earth moving applications. It works really well. And then just for the imagery as well, just for having a record as you're doing more of the MEP coordination and finishing touches. So let's go to Joshua's question. The data set shown, how long did it take to process once sent to the cloud? This is a very small one. This was only about 3 minutes to capture. So this processes in like a couple of hours. So pretty fast. For large scans, we're looking at probably about 12 to 24 hours. So that's something we're speeding up a lot, and it's going to get a lot faster. One of the reasons we're in a cloud is that you can do 20 scans in a day, for example, and overnight run them all. So you don't need to have local computers. This is all done in the cloud automatically. And the cloud is US based. We use AWS. Forest, how fast can it capture data? Could it be vehicle mounted like on a side-by-side while driving on a large site? Yes, today we have a speed limit of about 10 kilometers an hour, so about 6 to 7 miles per hour. Just drive slowly, make sure the camera doesn't see the vehicle, and you're good to go. Of course, you're going to be limited to what you can see. So if you're like looking to see what's inside of a ditch that you cannot see from the vehicle, we can't make magic happen. But if it works, then absolutely. Then comes the cost question. Yes, do you charge for data processing? Somewhat, yes and no. So we have a very interesting model, which is that we are 100% a lease-based model. So a full service lease, it includes access to the hardware. So you basically get one of these units. You get the full training, you get the full warranty. So in case you drop it, damage it, 100% covered, we drop ship you new units. And in case of upgrades, so let's say next year we release a new hardware system, you will get upgraded as part of that lease renewal. The software is included as part of that as well. And we have two tiers. The first one is $15,000 per year for the first capacity of processing, which is 250 acres per year. And then if you go above that, you go into the 750 acres per year bucket. And then after that, it's just basically 250 acre add-ons for 5K. So it gets very cheap towards the higher utilizations and very useful, right? So a lot of your guys' project, I assume, are a little bit on the smaller side, so you can get a lot of mileage out of this. And the initial upfront cost is very minimal. And we do US-based financing as well. So if you just want to do monthly billing, you can do that. But there's a 12-month commitment. Yeah, so annual commitments, but we do monthly financing if that is of interest. Right. I know this was a lot of content. I really appreciate everyone's attention. If you have more questions, I'm going to drop my email below. I promise I will get back to you, and I will also give you my phone number, which you can text and chat or give me a call, and I will gladly answer more questions. I always like to say, don't believe anything I say. Try it out. So if you guys want to see it, let's get on the job site together and run this through its paces, check the accuracies, and see how it can be used in your projects. So with that, I thank you all and look forward to being in touch.